folks. Today we are going to continue our discussion of chemical bonds and build off of what we talked about yesterday with valence electrons. So we're actually going to do a bit of review from yesterday and kind of put yesterday's material into a little bit different context using some picture notes as opposed to just your standard notes that we did yesterday. So let's go ahead and get started. Our learning target continues to be, I know why atoms make chemical bonds. All right, folks, so what I need you to do is I need you to go ahead and open up your packet. And in your packet, you're going to find a sheet that looks like this. It says C.1 ions. And we're going to go ahead and fill this out together. So what I'm going to need you to do is make sure you have this sheet in front of you. And then I'm going to switch here in just a moment, and I'm going to be filling out this sheet with you. And so you'll just draw what I draw and follow along with me. So I'm going to have you make sure and advance the Nearpod to this slide because we are going to be referring to the periodic table and the noble gases. So I want you to have a visual reference. And so here's what you should have access to. You should have the periodic table of elements, this slide on your Nearpod. You should have your picture notes, the C.1 ions in front of you, and then you should be ready to watch this video. So once you have all of those components ready to go, you can go ahead and continue in this video and we will go over the picture notes. Alrighty, folks, we are going to go through and see if we can't visualize how ions are formed from atoms. So just follow along with these notes and just write down what I write down. All right, so we're going to be starting off here thinking about fluorine as our example. So all I've done here is just write the periodic square for fluorine, which is atomic number 9. So number 1, each proton has a positive charge. So if we're drawing fluorine, that means that we have 9 positive charges in the nucleus of the atom. All right, and each of those is represented by a plus here. We also know that that each electron has a negative charge. So let's go ahead and kind of draw a little bit of a Bohr model here, where we're going to draw our first energy level with 1, 2 electrons. And then we're going to draw in our next energy level, leaving space here, 1, 2, 3, 4, 5, 6, 7 valence electrons for a total of 9 electrons. So from this, we also know that there are an equal number of protons and electrons in an electrically neutral atom. Okay? So protons and electrons are equal to each other. And because of that, we have 9 plus charges in our fluorine, and we have 9 minus charges in our fluorine. Okay, so that means that each positive charge has a negative charge and vice versa, and that means that there are 9 positive charges and there are 9 negative charges. If you add positive 9 to negative 9, you get 0, and that is our fourth point, that atoms have an overall neutral charge. Now, when it comes to atoms, protons are stuck in the nucleus. Therefore, only electrons can move, and therefore atoms can only gain or lose electrons. So let's say, for example, we had a sodium atom. Here's the Lewis dot diagram for sodium. And we have our fluorine atom. Here's the Lewis dot diagram for fluorine. Okay? So what that means is that this sodium atom really wants to get rid of its 1 electron, and fluorine really wants to gain 1 more, so both of them can achieve the octet rule. Therefore, sodium is going to give its electron to fluorine. So that means that sodium here loses an electron and fluorine gains an electron. And that's really the only movement that can take place in an atom, is the movement of electron between atoms. Okay? So what exactly is going on when an atom gains or loses an electron? So let's start with gaining an electron. When we add electrons, we are adding a negative number to the 0 charge of an atom because each electron has a -1 charge. So let's look at part A right here. We are using the math equation 0 plus -1 equals. So if we do the math for that, we know 0 plus -1 equals -1. But what exactly are we saying? So let's break down each of the parts of this equation. We're going to start here with the 0. And what we're saying with the 0 is a neutral atom because a neutral atom has no charge. And then we have this plus here, and that means it gains. And then we have this -1 right here, and that means 1 electron. Okay, so a neutral atom gains 1 electron, and we then know, or and then this equals -1. That means resulting in an ion with a -1 charge, or a -1 anion. So that's what we are saying when we do the math here. 0 plus -1 equals -1. If we were to add 3 electrons, it would be the exact same thing. A neutral atom gains 3 electrons, resulting in an atom with a -3 charge. Okay? So that's what happens when we are adding atoms. So this would be like fluorine, for example. It gains, I'm sorry, when we're adding electrons. So fluorine gains an electron. If we go down here to part 7, we can see that we are instead removing electrons, which means we are subtracting a negative number to the 0 charge of an atom. So all we're doing here is we have a minus instead of a plus, and that minus means loses. Okay? And so a neutral atom loses 1 electron, resulting in an ion with a +1 charge, because now there's 1 more proton than there is electrons. If we were to remove 3 electrons from an atom, a neutral atom loses 3 electrons, resulting in an ion with a +3 charge. That's all we're saying when we're doing the math. It's just a different way of defining it. All right, so how do you figure out how many electrons an atom gains or loses? Well, atoms are going to try to look like the noble gas with the closest number. So let's go ahead and for example here, we're going to look at oxygen, and we're going to look at magnesium. Okay? So all I'm doing here is just listing their atomic numbers. And instead of thinking about the periodic table as a big thing, or the table the way it's organized, we're just going to kind of think about it linear, or in a linear fashion, from one to whatever number we're going to go up to. So we are dealing with magnesium and oxygen. So what we're going to do is we're going to say that oxygen and magnesium, or oxygen wants to look like the nearest noble gas. Well, oxygen can either try to look like helium, or it can try to look like neon. Neon is only 2 steps away, whereas helium is 6 steps away. So oxygen is going to try to look like neon, which is number 10. Okay, so that is oxygen's goal, is to have the same electron configuration as a noble gas, because noble gases are inert and don't react, and basically atoms want to have that type of configuration. Magnesium, on the other hand, it can either try to look like neon, or it can try to look like argon. Neon is 2 steps away from magnesium, whereas argon is 6 steps away. So magnesium is also going to try to look like neon, for the same reason that oxygen does, because you want to have the same electron configuration as a noble gas, because noble gases don't react. And so in order for oxygen to look like neon, it's going to have to gain electrons, and in order for magnesium to look like neon, it's going to have to lose electrons. So how do you figure out how many electrons an atom gains or loses? Well, let's look at oxygen. Oxygen is number 8 on the periodic table. Fluorine is the next element, number 9. And then we have neon at number 10. And so, in order for oxygen to have a similar electron configuration to neon, it would need to take 2 steps to the right. 1, 2. And when you take steps to the right on the periodic table, so you go from a lower atomic number to a higher atomic number, in terms of electron configuration, you are going to be adding electrons. So in this case, since we took 2 steps to the right, a neutral atom, oxygen, gains 2 electrons, resulting in an ion with a -2 charge. Let's say we're going the other direction, and we have our magnesium, which is number 12 on the periodic table. Magnesium then goes through sodium, number 11, and then neon is number 10. And so in this case, in order for magnesium to look like sodium, or like neon, it needs to take 2 steps to the left. 1, 2. And so in this case, what we're saying is that a neutral atom loses 2 electrons and has a charge of +2. So magnesium takes 2 steps to the left, and that means you're removing 2 electrons. So if you want to look at the periodic table and figure out how many electrons a atom gains or loses when it takes on a noble gas configuration, that's one way to do it. The other way to do it is to just go ahead and look at your Lewis dot diagrams. So let's take a look at oxygen. Oxygen's Lewis dot diagram has 6 valence electrons, and it starts out with a neutral charge when it has 6 valence electrons. Now, when oxygen becomes an ion, it needs to have a full valence shell. So it is going to have 8 valence electrons, so it now has 8 valence electrons. In order to get to 8, we need to add 2 electrons. And then when you have a neutral atom that gains 2 electrons, it results in an ion with a -2 charge. So right there, we have our oxygen ion with a -2 charge. Let's do magnesium. Magnesium has 2 valence electrons, and so it has 2 valence electrons with a neutral charge. Now, magnesium, in order to look like a noble gas, if it gets rid of its 2 electrons, its uh, inner electron shell or inner energy level will become its outermost energy level, which is already full. So it will have the same electron configuration as a noble gas. So what we're going to do is we're just going to go ahead and draw it with magnesium with no valence electrons around it, meaning that the inner shell becomes the outer shell. And so we can just go ahead and say it now has 0 valence electrons, which would mean that the inner shell would become the outer shell. But just for the sake of understanding, we're going to say 0. And that means that it lost 2 valence electrons. So a neutral atom loses 2 valence electrons, resulting in a +2 charge on the ion. And so this is how we figure out the charge on different ions. All right, so now that we've gone over that, let's really quickly one more time visualize what exactly this means. So let's go ahead and build ourselves a beryllium atom, having our net charge turned on. We have a beryllium atom with 1, 2, 3, and 4, 4 protons. And that means we have 1, 2, 3, and 4 electrons. All right, so beryllium is highlighted right here on the periodic table. The two closest noble gases, which is that far right-hand corner, are helium and neon. So in order for beryllium to look like a noble gas, it either needs to look like helium or neon. To look like helium, it takes 1, 2 steps backwards, or to look like neon, it takes 1, 2, 3, 4, 5, 6 steps forward. We always want to take the path of least resistance. So beryllium is going to take 2 steps back, 1, 2. And remember, when we go from a higher atomic number to a lower atomic number, in terms of making an ion, we take away electrons. So we take away 1 and we take away 2. And we can see that results in beryllium forming a +2 ion. Now, let's try it on the other side of the periodic table with nitrogen. So we need 7 protons in our nucleus, and we need 7 electrons surrounding our nucleus. All right, so now that we have our electrons, we look at nitrogen and we see, okay, which one, or it can either look like neon or helium. Well, if it wants to look like helium, it needs to take 1, 2, 3, 4, 5 steps to the left, or if it wants to look like neon, it takes 1, 2, 3 steps to the right. It is easier for it to look like neon, therefore we're going to take 3 steps to the right, meaning that we go up in the number of electrons / atomic number, so that means we add electrons, 1, 2, and 3. And because we added 3 electrons, we add a -3 charge, and it becomes a -3 anion. So once again, just kind of helping to visualize what we just talked about. All right, so to go back to yesterday, we filled out our Lewis periodic table, and from that we were able to figure out which cations and anions form for each group. And the pattern that emerged is that all of the elements that have 1 valence electron, they lose that valence electron and form +1 cations. All the elements that have 2 valence electrons, they lose both of those valence electrons and form a +2. For 3 valence electrons, they lose the 3 and become a +3. And those are all metals. Okay, so metals all lose electrons and become cations. Nonmetals, on the other hand, they gain electrons because they are closer to the higher atomic number noble gas. So neon or nitrogen and phosphorus gain 3 electrons and become a -3 anion. Oxygen and sulfur gain 2 electrons and become a -2 anion, and fluorine and chlorine gain 1 electron and become a -1 anion. And just once again to review those words, a cation is going to be a positively charged atom due to loss of electrons. All of our metals become cations. And an anion is a negatively charged atom due to gaining an electron, and the nonmetals become anions. We remember that cats are good, positive, cations positive. Anion sounds like onion, and therefore onions are bad or negative, and so anions are negatively charged ions. Alrighty, now that we have that, let's go ahead and talk about bonding. And this is where we're adding to yesterday's notes. Bonding, this is the sharing or transfer of electrons between atoms that holds them together. So we've kind of just been adding electrons and taking away electrons willy-nilly without putting them anywhere, but in reality, those electrons are going to come from other atoms. So if you lose an electron, that's because you're giving your electron to another atom. If you are gaining electron, that's because you're taking it from another atom. And at that point, you have two atoms forming ions. So in this case, we have sodium giving up its electron, becoming positively charged. Fluorine gains an electron and becomes negatively charged. It becomes a cation and an anion. And so we know that opposites attract. That is kind of one of the principles of electricity. And so when you have a positively charged ion and a negatively charged ion, they are going to be attracted to each other. And so this is what a bond is. These ionic bonds happen when these electrons transfer completely. The oppositely charged atoms are attracted to each other. And because sodium has a +1 charge, fluorine has a -1 charge, when they get attracted to each other, that +1 and -1, they cancel each other out. If you add +1 to -1, you get 0, and we once again are back to an electrically neutral combination, which is ultimately what we are going for. So we have both atoms satisfying their octet rule, and they are electrically neutral. And so we have satisfied what is two energetically beneficial states for the atoms individually and the atoms as a whole. What question does the previous slide answer? Alrighty, folks, I want you to take this quick ungraded quiz to see how you do. Pause the video, take the quiz, and then come on back. All right, question 1. How many electrons does an atom want in its valence shell? That is going to be 8. Octet rule. How many valence electrons does magnesium have in its valence shell? Magnesium has 2 valence electrons because it is in the second column. Would sulfur gain or lose electrons to make an octet? Well, sulfur is in that 6a column, and so it has 6 valence electrons, and so it is actually going to gain electrons in order to form an octet. What would the charge of a sulfur ion be? Well, sulfur gains 2 electrons, and therefore it would form a -2 ion. And finally, is this sulfur ion a cation or anion? Well, it is negatively charged, so it is an anion. And if you answered those questions as such, you should get a 5 out of 5. Alrighty, so with that being said, folks, I want you to go ahead and self-assess. How well do you understand chemical bonding? 1 is super lost, 5 is I could teach this, and just kind of figure out where you're at. Give yourself a little bit of a self check-in here. So, alrighty, folks, so that's it. Please check the Schoology folder, today's folder, for a key to the notes, so that the picture notes, so that you have that completed. And if you have any questions, please feel free to reach out to your teacher. Have a great day.